Hello, I'm Mark, and welcome to my Unreal Engine tutorials on how to add support for wheeled vehicles into your physics movement component. So as you can see here, I've got our little RV as we kind of, again, demonstrate the vehicle. And so in the last video, we went ahead and added a mass to our settings so that we can manipulate how much mass the vehicle is and where the center of mass is. And we needed to do that because the way that Unreal Engine calculates mass on a vehicle, on a mesh or a skeletal mesh or a static mesh, is by calculating the weight of the material, right? And it uses that to figure out how heavy an object is going to be. So we, when we're kind of building things out, we want to then, we may want to change the mass of the vehicle, especially if we're starting to scale things up or scale things down within the physics system. We may need to change those settings. Again, where based on your mesh, right? If we're using a vehicle that was created for pawn movement, which means it's going to have a root bone, our physics particle is going to attach itself to that root bone, and that's not necessarily where we actually want the center of mass to be. So again, by default, where the center of mass on a physics particle is also going to be where it attaches itself to. So in order to get around the root bone, you may need to move that center of mass up. So by us moving that center of mass up, we can kind of start to get this vehicle to sway a little bit. As I kind of put some extreme turning in there, you can kind of see it kind of moving slightly from left to right. Okay, that's what we did in the last video. So in this video, what we're going to do is we're going to go ahead and start focusing on taking the throttle input and turning that into engine torque. And so once we have that engine torque, we can then translate that through a transmission, right? So that we can turn that into wheel rotation. And from wheel rotation, then we'll be able to create friction forces on those wheels so that we can move across various surfaces. A lot of C++ to get through in order to create that engine simulation and then hook it into our component. So as always, we got a lot of ground to cover, so let's get started. Okay, so let's get started with the engine simulation setup. So I'm going to go ahead and add that into the simulation configurations.h, since that's where I'm going to be putting all of our structs for our simulation setups and configuration. So I'm just going to go ahead and I'm just going to copy this from the other solution and bring it in. I'm going to have to change the API so I can get rid of these red squigglies. All right, so this is the engine simulation. So again, it's struct, and I'm just to kind of keep things together. I'm just going to be adding. I just added the tag name and the enable. Again, just to kind of keep some similar, some consistency within my setups. But the things that we want to take a look at are going to be the first one is going to be the torque curve. And then we have the torque curve multiplier. So this is something where, when simulating an engine, right, you can have a linear torque if you want to do something a little bit more like a golf cart, but most engines have an optimal, power band, so as you're kind of, at the lower end, it's maybe not as efficient, and at the higher end, it's maybe not as efficient. So there's usually somewhere within, it's going between 0 and maybe 6,000 RPM, right? There's an optimal place where you'll get your maximum amount of torque, and then it kind of drops off it, so it'll kind of ramp up a little bit and drop off. So if you kind of want to simulate that, you can go ahead and use a torque. And I put a torque curve multiplier in here. That way, if you want to kind of reuse a torque curve, so instead of going from 1,000 to 6,000, right, you could decide that you might want to, say, instead do something like 1 to 6 and then use the multiplier to put the thousands in, to that way you can reuse a torque curve in other vehicles and just change the multiplier to change those values. So that's kind of what I did there. Can be pretty useful, especially as you're kind of getting a feel for building out, trying to simulate the engine torque and the revolutions per minute. Max torque, so this is the maximum amount of torque that the engine gives. Right, I've just set this to 300, but again, it's up to you on how high you want that set that torque value, and you can do that. We'll do that in the component. Max RPM, again, this is the maximum revolutions per minute. This is the idle RPM, so this is how many revolutions you'd be doing if your engine is just idling. You turn the car on, the engine is just naturally idling, but we're not putting any more additional gasoline into the accelerator to kind of start moving things, to revving it up. Engine brake efficiency. This is us trying to then simulate some friction in the engine. So, when you rev up an engine, it'll go up, and then when there's no gasoline, the revolutions start to drift back down again. So this is kind of where we want to put that kind of engine braking efficiency in there. To see how much it wants to starts to come down, especially when the vehicle's in gear, right? If the revolutions start to come down, then the transmission will actually start to get the wheels to slow down, which will then create braking friction for us without us having to touch the brakes. So that's kind of what we're trying to simulate there. And then we have the engine up RPM rate as well as the down RPM rate. So again, they're slightly different because they work slightly differently, but the idea is that if this, on an up rate, this is how much we'll be using to increase, versus this is how much when we take the foot off the gas, the accelerator, this is how much it's going to decelerate the engine back down again. And then, as always, I like to put a little engine condition percent if you want to use that to play with during the simulation. As you're kind of putting wear and tear on the engine, you can then make take the efficiency of the torque and start to degrade it if you wanted to. Again, it's a percentage, so it's between 0 and 1. And then these are all the functions that we're going to be using. Looks like I'm going to have to go ahead and copy that in, but we'll talk about these when we get to it. And then we also have some private variables, so we'll be running the engine simulation within this struct. So these are the values that are going to be tracked during the life of the engine simulation. So we got throttle, so there's the throttle position, so this is the accelerator, how much gas is, are we 100% or are we 5%, how are we flatlining the accelerator. And then we have the target speed as well as the current RPM, drive torque, engine idle speed, max speed. Again, is the engine on? By default, I think I have, well, here I have it false, but I think in the constructor or as part of the init, I'll actually turn it to true. Free running is, are we in gear or are we not in gear? So if we're in neutral, then we have no load, then there's no torque, we're not sending any torque to the wheels, the engine's just running. And then we have the current omega. So this is useful when we start getting into transmissions, which I think will be the next video. Where we'll then want to then take the torque coming off the engine and turn it into axle rotation. All right, so that is, so these are the properties, these are the private functions. So let's get started with the actual, adding the implementation in here. So first off, we have, the ones which we don't need to worry about are simple getters and setters, right? So we have the start engine, which is just a little, which takes a boolean. So I should, that should be, we can keep start engine for now. It just takes a boolean, and we just set the boolean if we want to have an external way of starting and stopping the engine. You can use that. Set throttle, again, we're taking, here we're going to clamp it between 0 and 1, since the throttle, we don't really have negative throttle. So we're just going to set it between 0 and 1, and we're just going to clamp it, but that's the throttle position. We have set, what else do we have here before we need to start talking about implementation? We have the get engine omega, so this is the omega, and then we have the set engine omega. Right, so we'll be working between omega and RPMs. What we want is the RPMs coming out, but while we're in the engine, we'll be working with omega instead. So we will need some conversions up and down. All right, so let's get started with the implementations, and I will get to simulate last, I think. So the first one is going to be get the torque from RPMs. So let's see what this is going to do to fix it. Nope, we don't want to put it there. So I'm going to have to do this the old-fashioned way, and we're just going to go and add these functions to the simulation configuration.cp. All right, so our first function here is going to be get torque from RPM. So let's go ahead and get the torque from RPM. It's buoyant forces, we don't need that. All right, so this is the get torque from RPM, and so what this is going to do, so if we go back to this function, what we have here is we have the engine RPM, which is going to be something that we're going to be putting in. So think of this simulation as an additive process, right? We're going to be adding, we want to add to the RPM if we're accelerating, and then if we're decelerating, i.e. through engine braking or through, braking the wheels, then we want to then start to, we'll start taking some of that out again. Providing we don't have a throttle position, we're not adding gasoline through the throttle position. Also, this function has a default value here, so limited to idle is set to true by default, and so when we come to the implementation, as you can see here, this is going to be assumed true unless we override it when we call the function. So again, we want to check to see here if the engine is started. If it's started, then what I'm going to do is I'm going to use an absolute value of the engine RPM coming in minus the maximum RPM. So again, we're checking to see if we're actually running. If we're not running, then then any torque coming off the engine is going to be 0. If we're idling, then we're just going to take a look at what's coming in here, and we're just going to clamp it between the engine idle and the max RPM. So this is like the minimum RPM that an engine has, and then this is the maximum RPM. So we'll have some kind of RPM if the engine is, even if it's idling, right? We're going to have something in there, and this is going to let us know if we're idling or not. If we're not idling and we are started, not idling, then we'll come down and check, do we have a torque curve? If we're going to do the torque curve, we'll take the engine RPM going into the torque curve, and then we're going to go and use the torque multiplier. That way we can kind of normalize, get the real value that we want off that curve. If the curve is perfectly fine, then you'll use a multiplier of 1, but if you want to increase it by 2 or 1,000, you can do that. Otherwise, if we're not using a torque curve, then we're going to do a linear, and so to do a linear, what we're going to do is we're just going to take the max RPM minus the engine to get the diff. We're going to take the diff multiplied by the torque, divide that by the max RPM again, and then divide that by our max torque value, right? And then that should get us where we are on that linear slope between between the engine RPM and the max. All right, so that should do it for that implementation, that function. So the next function, I'll just stay in here, is going to be the set engine RPM function. And then this is going to be a simple one. So what we have here, and as you can see here, I've got this physics simulation utility function that I need to define. So we'll go ahead and define that. But here, what we're going to be doing is we're checking to see if the engine is free running, and this is going to be set from the train, depending on whether we have the transmission engaged or not. And then this is going to be the engine RPM. So this is going to be coming in from the mechanical simulation that will be running in the physics loop. And so we'll first check to see if we're engaged. If we are not engaged, right? So this is saying that we're in neutral. So as long as we're not in neutral, we're going to go ahead and take the absolute value of the RPM, right? And then we're going to clamp it between this and the idle to get us the RPM, the omega, because that's what we want, is the target speed, not the revolutions per minute, but the speed, and that's what omega represents. So let's go ahead while we're here and define this simulation utility function. So to do that, we actually have a file that we've been putting utilities in. So I'm just going to go and I'll pop this open. So this is our physics simulation utility, and we've got some conversion utilities in here. So this is a good place for us to go ahead and start adding some more. And I'm going to, while I'm here, I'm going to add two functions. One is RPM to omega, and so it's going to take an RPM in, and then this is just the equation that you can do in Unreal Engine to take revolutions per minute and translate it into omega. And we also have omega to RPM because we're going to want to convert it back from omega back to RPM again. So we put the omega in, and so this is the reverse conversion function. All right, so now that I save that, I should be able to come back to the CCP, and this guy should be fixed. If not, I need to add a reference as well. So let's just go ahead and add that reference. So to do that, I'm just going to go ahead and say pound include. And this is, where is it? Where is it? Physics simulation, is it in the same? Should be physics simulation utility. Hang on, what do we need to do here? Simulation, there it is. Physics simulation utility. So that should reference our simulation utility, and there it is. Okay, so this is the new function. So again, this is RPM to omega, and we will be using the other one to go back once we're in the simulation. All right, so that sets that is setting the engine's RPM. So the next one is going to be getting the engine torque, which will be getting the engine's omega, or the torque, I should say, not the omega. All right, so here we are. This is just get engine torque. So again, make sure our engine is started, and then this is okay. So this is going to be get torque from RPM. So this is calling this function up here, where it'll go through and determine which of these if statements it wants to use, right? And then return, and then as you can see here, so here we'll return 0, or we'll return a curve, or we'll return the linear. And then what we'll do is we'll then take this, multiply that by the throttle position, and then that should be getting the engine torque for us. And the current RPM, this is what's being set in the simulation. And then again, if the engine's not started, we'll return a 0. Next is get the current RPM. Pretty simple. Again, just like get engine torque. If the engine started, we'll get the current RPM value. Otherwise, we just get 0. Again, keep it simple. And then before I get to the simulation, I'm just going to go ahead and get the initialization function. So this is our initialization function that we'll be using when we do the engine during the setup, so that we can initialize the engine. So again, we want to make sure that the internal engine speed, RPM to omega, that's taking the idle. So this is the engine idle speed, which is omega. This is the max engine speed, which again is measured in omega. So we're taking the RPMs converted to omega. And then we have here again the engine is now started, and 2 is free running. We're going to assume that we're going to be in gear. All right, so that should do it for all of the functions except for the most important one, which is simulation. So let's go ahead and bring that one in real quick. So this is how we're going to simulate our engine during the movement simulation. So here again, delta time, everything's by delta time. So again, first off, is this thing enabled? If it's enabled, if it's not enabled, we're just not going to run it. Is the engine turned on? If the engine's not turned on, then we're just not going to run it. Are we now? This is where we want to check to see, are we in gear or are we not in gear? If we're not in gear, we still want to rev the. We might still want to rev the engine, which would then go into, if you wanted to have speed dials go up and down while the vehicle's not going anywhere, and have that sound of vroom 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 while you're not going anywhere. Then this is where you can use this. So again, we're going to get the engine torque, delta time, and get the current omega. What we're going to do is we're going to check the throttle position, right? If we're increasing, right, then we're okay with this. If we're not on the throttle, then we want to decelerate. Right, so again, here we're checking the throttle position. Are we putting gas in? If we're putting gas in, we'll just take the value as is. If we're not putting gas in, then we need to use the deceleration, and this is done by the down rate. So we have the omega, the engine idle speed, max speed, get this squared, and then we just multiply that by the down rate, which will give us the deceleration back down to our idle state. Then otherwise, if we're in gear, right, so if the transmission says, okay, we're in gear 1, gear 2, gear 3, or whatever, right, then again we want to check the throttle position. If we're not putting anything into the engine, then again we want to decelerate. Otherwise, if we are giving it gas, we want to accelerate, and so that's what that's going to do there. And then finally, we want to check to see if the omega is less than the engine idle speed. We want it to be the engine idle speed. Again, this is just a final check, just in case any of these calculations dips below the engine idle speed. We'll set it to the engine idle speed. Current RPM. Again, we want to then take the omega, since everything's being calculated in omega, right? And we want to then translate that back out into current RPM. So again, and I just multiply this current omega by the engine condition percent. All right, so that should do it for our engine simulation. So we've now got all that. So all of our green squigglies should go away. All right. So now that we've got this out of the way, I think the next place we're going to go to, and we've got the simulation utility done. I think the next thing we're going to do is I'm going to go ahead and stub out the wheels. While we're not going to be doing anything with the wheels in this video, and probably not do it for the next, for a couple of videos, everything still revolves around ultimately that wheel. So I'm just going to go ahead and start stubbing this out, and as we continue to go through these videos, we'll start adding more and more things into that wheel, so that we can, so that we've got all the pieces, and we can build on that stuff. All right, so let's get started with building out our wheel. Okay, so first up is I'm going to start off with the data. So what I'm going to do is I'm going to come to our solution, and I'm going to open it up. I'm going to come into our C++ classes, go to public, simulation, vehicle. So I'm just going to put our simulation here. So what I'm going to do is, since the wheel systems are going to require a lot more stuff, I'm actually going to put them into their own struct file. So I'm just going to do that, I'm just going to right click under vehicle, and I'm going to say new class. And since Unreal Engine doesn't have a blueprint for structs, we're just going to have to convert a standard C++ one instead. So I'm just going to click on none, go to next, and go and find ourselves give it a name. So I'm just going to go ahead and call it wheel. I'm going to call it wheel simulation. I'll call it config. I'll call it setup. I'm going to probably put the suspension setup in here as well, and just keep everything together. But wheels and suspension kind of work together here. But this will be the file where I'll be putting these new structs. Alright, so we've got that. It's under vehicle, so I'm going to hit create class, let Unreal Engine and Visual Studio do their things. hopefully everything should work. Reload that. All right, okay, good. All done. All right, so let's go ahead and just convert this from a class to a struct, and I want to make sure this is going to be a generated struct or a generated struct for Unreal Engine. So I'm just going to go ahead and just grab this. So I'm going to create this include file, generated.h. We always need this, and let's just make sure that that's going to be the last. This always has to be the last line of any generated class that's created. And I'm just going to go and turn that to an F. Make that a struct. And to do, I'm going to go ahead and put the struct tag on there, so it's a blueprint type. Generate body. Put an F there and an F there, and let's see. I'm going to do this. I'm actually going to take the destructor out since we don't really need a destructor for this. And that grand squiggly should go away. Alright, and then in this file, I'm just going to clear this out for now since we don't need it. Alright, so that should set us up with our wheel simulation setup. So this is going to be where we're going to be putting our wheel simulation data, and for now, all I'm going to do is put in a couple of properties that we need. So again, wheel mass, radius, and width. So this is in kilograms. This is going to be centimeters and centimeters. It's just how it's just the so centimeters is the natural unit of Unreal Engine and how it calculates. And then there's a lot. We're going to be putting a lot more data into here as time goes on. So these are the ones which I'm going to make blueprint visible, but there's going to be one that I'm going to make blueprint invisible, and that's going to be the engine enabled, and we'll determine whether this wheel has power or not based a little bit later when we get to transmissions and wheel differentials set up, and that will be able to, because that's what's going to then ultimately turn this on or off based on where this wheel is hooked in. So we'll just keep that there for now. Is there anything else I want to bring in? Not yet. Alright, so that is just the basic wheel setup, and this is just this is our wheel data. So the next thing I'm going to do is actually going to create a object which is going to be our wheel vehicle object. And I do actually like how this works. I kind of got this from Unreal Engine's chaos system, and after doing a lot of digging, I became kind of a believer in it, especially when you're dealing with systems where you've got lots and lots of systems. I'm actually in the process of rewriting this whole solution using this method a bit more, because it does make things a little bit easier on the blueprint side, especially when dealing with parts which could be multiplied, right? So this actually works really nicely. So let's go ahead and do that next. So I'm just going to come back here, come back into C++, Physics Live, Simulation, Wheeled Vehicles, and I'm going to right click and go to New Class. And this one, I'm going to go to All Classes, and I'm going to go pick the object. So this is again U objects. I use a lot of U objects. This is the base object within Unreal Engine, And so if you want anything which is going to be managed by Unreal Engine's garbage collection system, i.e. becomes managed runtime code, you want to derive off this. So this is the base class. Everything else, as you can see, every object in Unreal Engine that we play with actually derives off this. So this has the minimum amount of information that allows it to work within the Unreal Engine's runtime. So we're just going to derive straight off the object. So let's go do that. So I'm going to hit next. And for this one, we're just going to keep it simple. And I'm just going to call it vehicle wheel. And let's go ahead and create that class. And again, that's located in our vehicle folder. All right, once we have a good compile, let's go ahead and bring this in. And we'll just flip right over. So within here, what I'm gonna do, again, make sure that is at the bottom. I am going to put a reference to our physics simulation file. Include where do we put this? Oh, of course, wheel simulation. Yep, wheel simulation setup. So that's where it is. So that's where our struct is. So now that we've got a reference to our struct, I'm just going to go ahead and, since this is a class, I'm going to say, I'm going to put a public section in. I'm going to create a protected section and a private section as well. And I'm just going to go ahead and put this under protected. I know, under public. Makes it easier for us. All right, so again, this is blueprint read only. This is going to be where, so this is the struct that we created up here in the setup. I'm just going to close that for now. So right now, again, we just have these pieces of information. Again, we will be adding a lot more information here when it comes to wheels and how we want to configure our wheels. And within here, we'll be adding again another metric ton of information or data points and information that we need in order for our simulation to run smoothly when dealing with wheels and suspension. So again, we're just stubbing this out for now, and we'll then use this to build our simulation on top of it. And so while I'm also here, I'm just going to do two things. Under protected, I'm going to go ahead and put a rotation offset as well as a pointer back to our vehicle simulation components. So, and then finally, I'm going to add two more variables under private, and that's going to be the rotation point. So this is a rotation point offset, but this is going to be the actual rotation point of the wheel. And we'll need this rotation point for both the wheel as well as the resting point when we get to suspension. And then we have a wheel index because we need to try and keep these things in synchrony. So what we're going to do is we're actually going to be creating instances of the wheel. And since we have since the component knows about, when it creates it, is going to create it based on the setup, right? So we'll be creating a setup of the wheels, and we'll say wheel, 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 wheel. And then we need to make sure that we can link the wheel setup eventually with this wheel object. So we just need to make sure those index, and we're going to use this index for index mapping. All right. So that is, again, the basics. Oops, let me go ahead and put this thing there, and I'm also going to put a generate class body on this one. All right, so that's our object. That's the basic struct. This is the pointer object back to the component. Again, property transient. edit anywhere. This is a rotational offset, and then this is the resting place, rotation point and resting place of our wheel. And then that's the index. All right, so I think that will do it for now. If we need to add anything, we'll just come back. So next up is, so again, as we continue to set this up, I think next we need to set up our input simulations so that we can take that input from our controller and pass that to the simulation. So that's what we'll do next. Okay, so in order to pass the input into our simulation, right, we are using our vehicle simulation inputs traits struct. So we're going to be, again, coming in here and we're going to be adding some additional things to help support our vehicle, especially wheeled vehicles. So again, for this this solution and for this video, we created this thing a long time ago called vehicle movement traits. And this vehicle movement traits, quick refresher, it has our inputs as well as our state, right? And all of this is designed so that we can put it into this vehicle movement traits, which will then be, if we decide we want to use network replication, right, it will then replicate the at least the inputs, but it will also send the movement state as well down the network. And that is all done through the network physics data that we're deriving from. And so since we're creating this, we're also going to be just using this as well. And you could, I'm using this as a struct so that I can use this for both net, if I want to do it for network or non-network. It's just in a nice place, just to kind of keep things together. So while we're in here, or now that we're in here, I should say, we're going to go ahead and add our first new property in a while. And that is going to be our engine throttle input. So I wanted to keep this separate from these inputs. These are really the throttle. These are the throttle inputs that I'm using for the axes for our flight stuff. So, but for this demo, I decided I wanted to just keep this separate and put this into its own one. So this is the engine throttle input, and so when we hit the accelerator, that's where that throttle input is going to go. All right, so now that we've got that out of the way, let's go ahead, and we'll be coming back to this to add other inputs in over time. So, but now that we've got that done, we need to then go ahead and set up the implementation. So we're going to come into, so I'm going to now move over to movement traits, CCP, and in here this is where we have our, that is, let's see if we can find out, this is input. This is our interpolation, decay, and serialization. This is our archive serialization. And so this is very important when using the interpolation, right? If we, so the way that this system works is it uses network interpolation if we want to run over the network. And so the first thing we want to do is go ahead and update our decay. So this is the rate of decay that an input will have if this becomes networked, right? Then as time ticks, we need to decay that throttle input by a certain amount. So this is what this does. So this will decay that rate. So it's becoming more and more stale. As it becomes more and more stale, the throttle input will go from the amount all the way down to 0. Does it, net serialization. This is where we are going to, this is what the system uses to determine if the data packet or if the value that it has is stale or not, or is becoming stale, right? And that's why we're doing this. So this is just a bit shift. We're just taking all of the inputs, shifting them into this archive struct, right? And then what it does is it takes a look to see, if this archive struct is different from the archive struct that it currently has, that means we have a new data packet. With that means we want to use the fresh values that are coming in. Otherwise, if this is the same, then if this is the same as the archive, then we want to decay the rate, and then the next step is to interpolate it so that we can try and figure out, try and predict what that, is this the same, are we going in the same direction based on the frame rate, and that's what's going to happen in the interpolation. So I'm just going to go bring this one over. So let's just add this down here, and we'll be adding a lot more inputs into decay and interpolation, but this is the first new ones. So again, this is our throttle input. So again, we're going to do a min lerp and max lerp, and these are created based on the frame, right? And then this is the input, and then we have our lerp factor, which, so we've created all of this so that we can try and predict what this input is going to be, which will then run the simulation on all of the other networked vehicles, which will then try and help to continue to move that thing along based on the simulation data. All right, so that should be it for vehicle traits. So now that we've got the simulation, we've got the basic wheels, got the engine simulation, and we've got the traits in here now. So now we can come back, we can go over to our vehicle simulation component and start to hook all of this stuff in. So let's go ahead and do that. All right, so now we can come back to our vehicle simulation component. And so within our vehicle simulation component, the first thing I'm going to go ahead and do is I'm going to update our throttle input axis, because I'm just going to go ahead and reuse that function. So I'm going to create another enumerated value, and that enumerated value will be for if we're putting in a engine simulation. So I'm just going to go ahead and do that, and this is going to be the text I'll show up in the blueprint for this enumerated value. So that's the first thing we're going to do. Next, we're going to come down and let's see, that's our buoyancy. I'm going to put this on the buoyancy. So let's go ahead and add our wheel simulation. So the first thing I'm going to do is I'm going to go ahead and add a setting so we can turn this on or off if we need engine simulation. So this is just a kind of like a hard kill switch. So if we don't have engine simulation, we don't need to worry about this at all. And then I'm just going to put in a reference to our engine simulation setup. So I'm just going to copy that and put that there. So and I'll put a little distance between that and the controls. So there it is. So that's the setup we created in the simulation configuration. So that's our struct for our engine. And then once we have that, I'm just going to scroll down a little bit more, and underneath the speed brakes here for our input rate configuration, we're going to create another one, or add another one for our wheels. So again, we're just reusing the struct. So there's, great, we created this when we were doing back when we were doing the rate input configuration. So again, code reuse, it's a great thing. And then we're also going to need to, I'm just going to add this in here because we are going to need this even though we're not getting to wheels yet. I'm also going to put a little space here. This is going to be for our physics wheel, right? So this is our physics wheel pointer. This is the instant that we want. So I'm just going to come back, and this is going to be to our object that we created up here, which is our U vehicle wheel. I think I'm renaming it slightly different. You know what? I'm just going to go rename that. No, we'll just keep it with the other name. Keep it consistent. And I'm going to need a include file up here. Actually, this is what I'm going to do. I'm just going to go ahead and predefine it. Make this a little bit easier. Good old Microsoft. So what I'm going to do is I'm doing a pre-definition. This is mostly for the compiler, to let the compiler know that at some point this will get defined, but to kind of reserve it. And that way I can then define it when we get to implementation and have it in the implementation file. This is useful to prevent circular logic in the compiler. So we'll just do it there. Okay, so that's our vehicle instance. So what we're going to be doing is we're going to be creating an instance of these wheels. And what we'll do is during the creation phase, we'll create that instance and we'll then put that into this array. We'll get to that more when we get into the wheel stuff. But again, I'm just putting this here because our engine simulation will require a pointer to this. So I might as well just get that out of the way right now. All right, so we've got the switch, we've got the engine simulation, we've added the control so that we can manage the rate. So we can, if we wanted to change the throttle rates on the up rate and the down rate on the throttle, we can do that. We've got a reference to our instanced wheels, so that's going to be there. Next, let's come down to implementation, and again, we're going to be stubbing out a lot of several functions right now, and we'll be slowly filling them up through the life of in other videos, but we're going to stub them out here. So the first one's going to be our create wheel setup. So again, this is where we want to create our setups for our wheels, and I am going to, you know what, nope, I am gonna put this below buoyancy there. So again, that's just a function. We'll just keep the green squiggly for now. We'll come back to it. Next, since we're bolting a lot of things on, as you can see here, I've got update speed brakes. So I'm going to add the update wheel state GT. So again, there's a lot of other things that we need to update when it comes to wheels. So it's not just the position and the rotation of the vehicle that we need to update. We also need to update the actual, position, of the actual wheel itself. And that's the up-down position for suspension, as well as the rotational position of the wheel as well. So there's a lot of other information that needs to go in there. And we also need to update this on the physics thread as well. So just going to do that. So we have update state GT as well as PT. And again, since we're bolting a lot of things on, I had to create a function to help clear all wheel inputs. So that's what we're going to do here. So we have, so this will be specifically for any additional inputs that we need for wheels. We'll get cleared through that. As far as applying inputs and everything else, I think we're okay. But we are going to need a function for our mechanical. So, so we're going to be doing the first part of mechanical, which is engine, but we'll also be adding the transmission in here as well. So again, we'll be coming back to this over and over again, but we'll be adding this in. I'm not going to add any additional functions in yet. So then we're going to do an update on the throttle input. And is there anything else new here? Yes. And we're going to need a raw value. This seems a little redundant, yeah, but it isn't. These are the raw values coming in, and we always want to make sure that whenever we use a raw value that's going in, we also have to consume it, but we don't want to consume it on the input value, which is being run by the simulation, right? And we don't want to consume it there, with maybe the exception for any Boolean inputs that are going to be needed. But yeah, for the most part, we just want to make sure that we're only putting in clean, pristine data on the input side, and that the simulation is going to hold onto that data while it's running, while it's waiting for an input. And that's mostly because we're running between two threads. We have the GT and the PT. So all the inputs coming in on the game thread, while the physics simulation is running on the physics thread. All right, so that's the raw throttle input. All right, so now that we've got all that done, we can then start going into implementation. So let's go there next. I'm just going to go over to here. All right, so we'll start from top to bottom and we'll fill it all in. So again, nothing in any constructors. Begin play. Simulate physics thread. We don't need to do anything here yet. Actually, we do. We need to add, and I'm going to do this before the simulate physics tick here, right? So this is updating the state. So this is happening. So this is what we added a long time ago to update the simulation state of the vehicle under simulation state. Here I'm adding our update wheel state here, and again we'll continue to fill this out over time, but that's where it's going to be housed. So we could probably just put those together, and then after that we'll then we'll do the physics tick back on the parent component, and then we'll then apply inputs, update simulation, and apply forces. So that's nothing's really changed there. Then in here, let's see, did we add the stop movement immediately override? I don't think we did. Let's see, let's see, we've got this. Once you create. Nope, we need to override that now. So let's just go ahead and add that one in. So this is the stop movement immediately. So again, this is part of the pawn movement controller component. So what we're going to do is, again, we created an override, and we're going to be, and so we override that to clear out anything. But while we're here, we're going to just add a couple of more things into here so that we can, as we do the override, so we're overriding an override of an override. So we can just go ahead and add that right in. So I'm just gonna. So what I'm gonna do here, I'm just gonna go copy this and just put this right underneath the physics tick. So this is overriding again. So because we're overriding it, we want to make sure we call the parent. And then here I'm just going to say, if we call this, we need to clear out all of the inputs. That's including the clear raw inputs as well as the raw wheel inputs. And I think for now, is there anything else I need to clear? No, we'll just keep that there for now. All right, so. All right, coming back, that should do it. So the next thing is going to be our create wheel setups. So that is going to go here. I'm just going to go ahead and just fix this because I don't want to bring everything over right now. Make sure it puts it in the right place. Alright, so there's going to be a lot of things that we're going to be putting into here, but for now, the only thing that we need to bring over for our simulation right now is just going to be the throttle input. Did I not put a delta time there? Hang on. No, this is create wheel setup. My mistake. Is there anything we need in here? Yep, here it is. Engine simulation. So that's the only thing we need in there. Okay, so this is the create wheel setup. So this gets called in the setup sequence, and we'll add that into the setup sequence. So first thing we're going to do is we're going to set up the engine simulation, right? So we need to make sure that's all good to go. So that's what's there, and then that will run our initializer, which is defined here in our simulation configuration CCP. So again, that's just setting up all the basic values at runtime so that it will use those runtime values that we've defined in the blueprint. We'll be adding a lot of other stuff into here as time goes on. All right, so that's the wheel setup. So then next comes, okay, now comes the update state wheel GT and on the game thread and the physics thread. So I'm just going to go ahead and do that, and I'm just going to go ahead and do this. All right, so we've got both of these functions. I don't think we need to do anything on the physics thread for engine simulation, so I am just going to go ahead and we'll just keep this empty right now as a to-do. On the engine simulation, again, let's go ahead and just bring that function back in. So again, now this is what we want. Nope, not here. We want to put this up here in the game thread, since that's where that's being set. So again, this is our input simulation. So what we're doing is we're taking the raw inputs, and this is where we'll do our any interpolation based on up rates and down rates on that throttle value, and then put that into our engine throttle input, and then that will then get sent over to the physics thread. So that's the first thing we're going to do here. We're going to be filling this out with a lot of other information as time goes on. But that's what we're going to put in there for the engine simulation. Let me just check real quick. Is there anything else that I need to do here? Not yet. Okay, we'll hold off. Oh, while we're here though, at the bottom here we'll add the clear raw inputs. So just like we do for all of our other things. Ooh, you know what? That's what I wanted. That's what I was looking for, and that's what we forgot to do here. Need to clear that. Is there anything else in here that I clear? No. All right, so yep, so we clear the raw inputs. So that's always going to be the last line that we do. That way we clear everything out, ready for the next run through the loop. All right, so clear raw inputs is going to be next. And I'm just going to go and bring this all over. So again, that's our engine throttle input. We're just going to clear it. Ready for the next run, or ready for the next cycle. And let's take a look. Apply inputs. All right, so in apply inputs, we are going to go ahead and add a whole slew of new things for our inputs. And so within this, I am going to bring something over real quick. We don't have transmission, so I'm just going to take this out for now. So one, we want to make sure that the engine's enabled. And so if the engine is enabled, right, then we are going to do a couple of things. First off, well, this is where we're going to apply the input, the throttle input coming in. So, but I'm also going to add the engine braking value equation too. So what I'm going to do is just add this. I'm just going to put this down here. So what we have here is we have the throttle input, and we're just going to go and double it, so, or multiply it by itself. So we take the throttle input, multiply by the throttle input, and that will be the actual throttle input of what's going into the engine. And then under engine simulation, current RPM, we'll then multiply the current RPM by the braking efficiency, and that will be considered our engine brake. And we'll use that when we get into braking forces on the wheels when we get there. Again, there's going to be more that we need to add into this function, into this if statement, but for now, since we're just doing engine, we'll just do that. All right, is there anything else? You know what? Let's go ahead and add this as well, since we're doing it. So I'm just going to go type this for star wheel in where is it? Should be here. Let's just go grab it. Instanced wheel. So this is an array of pointers, so we're going to use the pointer notation for the wheel, and what we're going to do is we're going to take the, this is the engine braking force, and we're just going to go ahead and do a quick calculation here. Again, I'm just going to open this up because there's going to be more that we're going to be adding into here. But so this is going to be on the wheels. We want to add a engine braking force, and of course, wheel profile. Okay, so while we're here, we need an include. And this needs to go to our let's see. There it is. I think. All right, so let's see. See if we can get IntelliSense to work for us. Simulation, vehicle, that's the one we want. And while I'm here, I'm going to need the data part of this as well. Actually, no, we don't need that because that's being should be referenced here. Let's just double check real quick. Yep, that is. Okay, cool. All right, so simulation inputs, throttle inputs. Okay, so again, this is just going into the input, making sure that we've got a small input. If we're not using any throttle, then what we'll then do is we'll set this engine braking force based on. We just need to make sure that this particular wheel is a powered wheel, right? So we only want to put engine braking forces or engine kind of stopping forces on wheels that are tied to the transmission and the engine is actually enabled. So that's what we're going to set there. And we won't do anything else with this until we are well on our way to wheel and wheel friction. But we'll just add that right there. Let's see, we have update simulation. So let's open this up and just going to go ahead and add that function there. So that's our mechanical simulation function that we defined, and we'll go ahead, and we'll put the implementation in next. So under buoyancy, I think. Yep. So I'm just going to go ahead and do this instead. Okay, I can live with that there. All right, so under here, I'm just gonna do a quick check for the kill switch. So that's mechanical simulation enabled. So that's in the component. So if we're not using it, let's not even do anything within here. Then as part of mechanical, I don't have we're not doing the transmission in this video. We'll do the transmission in the next one. But what we have there is the engine simulation. Make sure that's enabled, and if that is enabled, then there's some things that we need to do on the engine before we pass it along to the transmission. So first part is the reason why I wanted to get the wheels in here. We need to get the wheels RPM. So I'm just going to comment this out real quick and come back to that. We need to get the wheels RPM. So how much are we actually, revolutions of the wheels actually doing, so that we can help to use that as a calculation to feed into our system. So one of the things I'm going to do is since we have multiple wheels which are powered, right, I want to take each wheel which has power and check its RPM, and then I'm going to average it out. That way I don't have one wheel doesn't have precedence, or there's no bias based on which wheel we're using. So it'll take any bias out of the system. And then I'm just going to add this in with error messages so that when we get to running this thing, we can see what's going on. And this is wheel speed. We only need this for the transmission part, which we're not getting to. I'm just going to comment those two out. We'll bring these back in when we get to transmission. As you can see, the transmission kind of plays back into the engine, and the engine plays back into the transmission. So, and as you can see, the wheels kind of play into that too. Everything's kind of intertwined. So we'll just comment these things out, and then when we get back to the wheels and getting the wheel RPM, we'll bring this back in. Once we've done the transmission, we'll get these back in. So we'll start adding more and more of these values in. Yeah, but each one kind of plays back into the other's simulation based on the previous state that it had. So that should set it up for the engine part. don't need that yet. Throttle input. Okay, so this is where I'm going to add that new case. And again, I'm going to clamp. This one is unique because it's clamped between 0 and 1. And under reset simulation, I've got braking simulation, inputs reset. I'm going to add the clear inputs, and I'm going to put that again here. Actually, you know what? I think if I just do this instead, right? We don't need to do this anymore because all three of those are being done in the overloaded stop movement mode. So if we just do this, and if this ever gets called, right, and we're going to call this when we do this, if we click a reset simulation, and all that's going to do is it's just going to go call our overridden, and this does all of that up there anyway, so we don't need to do it again. So we'll just do that there on the stop movement mode immediately. And on the tick, I'm just going to go ahead and add our wheel state GT. So that hooks that in. So this is the tick, this is the GT, which takes the input and passes it into our simulation inputs, so it can be used on the physics thread. And then we have the physics tick, which is actually going to then take the input, apply it, and then run the mechanical simulation. All right, so I think that does it for nearly everything. So I think what I'm going to do is I'm just going to go ahead and add this get wheel RPM in there, so I can unblock that, since this is just an addition to the wheel simulation. But then I won't then, like I said, when we do the video on the transmission, we'll go ahead and unblock this, and then there's some additional transmission stuff we'll add in here when we get there. All right, so let's go back and do the wheel profile. Okay, so in order to implement that missing function, I'm just going to go ahead and add a private section to our wheel simulation setup. So this is going to be private, and all we're doing is we're just going to go ahead, and I'm just going to include the note as well. So this is the omega, so this is the speed of the wheel. So we have engine omega, which is the speed of the crankshaft as it's idling or being accelerated or decelerated, right? That's the speed. This is the omega of the actual wheel, and omega is radians per second. So that's kind of what we'll be. That's our angular velocity in radians per second, and then we just change radians per second to revolutions per minute. And then we need the function to go with it, and that is the get wheel RPM. So we want to take the radians per second and convert it to RPM. So I'm just going to go add that function in here, and we need the physics simulation utility in here as well. So I'm just going to add that on the include. Actually, this one's a little different. There it is. All right, so again, we want to take the omega, convert it to RPM, since, so everything in our solution is going to be done in radians per second, and we just convert it back up. So, and anything on the, when we need RPM, we just scale it to omega, and we'll calculate it through that. All right, so I think that should do it for our engine simulation. And so let's go ahead and bring that back in. All right, cool. All right, so yeah, so I think that should do it for engine simulation. In the next video, when coming back into this component, we'll go ahead and implement a transmission. So we'll create a transmission where you can use either a manual or automatic, depending on your your game preference. So we'll do that there. So again, if you like what I'm doing, feel free to subscribe to my channel and give a like to the video. And yeah, I'll see you in the next video. Cheers. Bye.